Hey guys, water potential in a nutshell. So let's say we're talking about a cell and it's in some solution. And it has proteins and salts and sugars. It's got a lot of things dissolved in it. Just for this model, let's say this is just pure water, distilled H2O. So we could say a few different things here. We could say that this is hypotonic to the cell's hypertonic. We could say that this has a low osmolarity and this has a high osmolarity, higher anyway than the surrounding solution. And we could say that this has a high water potential and this has a low water potential. And remember that water always moves from hypotonic to hypertonic. It moves from low osmolarity to high osmolarity. It moves from high water potential to low water potential. It goes from the place where it's more watery to the place where there's more stuff dissolved in it. And so when we go to calculate psi, the equation is simple. It's psi p, which is the physical pressure, which you really only find in plant cells because they can handle that kind of physical pressure, plus psi s, which is the water potential due to osmolarity. Psi s is equal to negative I CRT. So it's going to be a negative number. I, of course, is the ionization constant. So for glucose, I would be 1. For sodium chloride, because sodium chloride, when you put it in water, it dissociates into sodium ions and chloride ions, that would be 2. For something like calcium chloride, right, that would make a calcium ion, a 2 plus ion, and 2 chloride Cl minus ions. So I would be 3, and so on. So it's just how many particles it forms when you put it in water. C is strict concentration, that'll be in molarity. R is a constant that you have on your equation sheet, and T is the absolute temperature, so it's the temperature in kelvins. So this is always going to be a negative number because of that negative at the beginning. And so any calculations that you have to do are pretty straightforward. It's just algebra. Whenever you're talking about osmosis, and that's the diffusion of water across a semipermeable membrane, and you should use that definition if you use that word. So the water is going to move from high concentration to low concentration. And virtually all cells have aquaporins, and so osmosis is constantly happening through their membrane. And really, that's all there is to it. Like I said, it shouldn't be too complicated as far as the math goes. It shouldn't be too heavy. That's water potential in a nutshell.